When ESA's Solar Orbiter launches from Cape Canaveral on an Atlas V rocket, its mission team will be more than ready. They will be ready for anything. At the European Space Operations Centre in Darmstadt, Germany, crucial parts of the spacecraft's journey have been rehearsed over a period of 5 months inside the main control room. This mission simulation is the final one before the dress rehearsal and the launch itself. 2 teams in 8-hour shifts take turns to provide spacecraft control from launch onwards around the clock. But the simulation is deliberately designed to not always go like clockwork, as problems and last-minute changes will be introduced to ensure that the team will be prepared for anything, no matter how unexpected.
So failures range from spacecraft issues, for example, after separation you don't have the signal from the spacecraft, or failures on board of prime units, we have to be ready to react, down to we have to make sure that all our ground systems are ready for us to be able to control the spacecraft, so we can get control system errors on ground or antenna issues, so the antenna which allow us to talk to the spacecraft. We can also have sick people as failures, so we need to be able to react to any contingency. Or, for example, to evacuate the main control room in case of whatever issue. We have a backup room in another building here. So all these things are trained and sometimes all together at the same time, so it gets quite interesting.
Today's simulation rehearsed the first day of the mission from the separation from the launcher onwards. The trajectory required to get from the Earth to observe the Sun has been designed and optimised by the mission analysts. Solar Orbiter will use a ballistic trajectory, which means directing its orbit by using gravity assists.
A gravity assist is flying by very close to a planet in order to use the gravitational pull of this planet to change the orbit. This we do repeatedly with Venus 7 times and with the Earth 1 time. By doing so, we can finally achieve an orbit that is elliptic, gets close to the Sun, and that goes out of the ecliptic. The ecliptic is the plane in which all the planets are orbiting the Sun. And by going out of the ecliptic, we get to high latitudes and we can get very clear observations of the Sun poles.
These high latitudes mean Solar Orbiter will provide the first images of the Sun's poles, as well as investigating the heliosphere and the solar wind. And these simulations play an important role in ensuring that not only will its team be mission ready, but that Solar Orbiter and its science will be a success.